Corporate finance practice problem using OneNote. Zero coupon bond, effective yield to maturity. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon, left-hand side, we're in the practice problems, then down in the 1622 zero coupon bond, effective yield to maturity tab. Also note, when using OneNote, look at the Immersive Reader tool. Our practice problems will be mirrored in the text area, same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we have our information up top, going through the calculations on down below. We're looking into a zero coupon bond, calculating the effective yield to maturity. Note, for normal bond calculations, this being different in that we have the zero coupon bond, normal bond calculations, take a look at the prior section where we spend a little bit more time on that and possibly doing the calculations in a few different ways. Also note that if you're looking into the present value type calculations, take a look at a prior section where we do those in a few different ways, including formulas, Excel, and with the use of tables. So we have the zero coupon bonds. They're going to say that the mature at the $1,000, the sales price is going to be the 550, years to maturity is going to be 10, and they're zero coupon bonds. So what we don't have then is going to be the yield to maturity. We don't have basically the rate. Now, this is different than like a normal bond in that we have that zero coupon bond, so we don't have the rate that would be on the bond, in essence part of the issuance of the bond, due to the fact that it's a zero coupon bond. What we're looking for then is going to be the rate for the, basically the market rate or the yield to maturity rate. So that should make it easier than the case if you were talking about a normal bond, because when you think about the calculation of a normal bond, usually, and I think it's easier to think about the calculation as if you're trying to get to the sales price, because that's what traditionally we would do. And then when you're looking for the yield to maturity, we can kind of reverse that thought process. Usually, you have to take the annuity of the payments that are going to take place, the interest payments, plus the present value of the single amount of the 1,000. Here, we don't have to take the present value of the interest payments, or we wouldn't have to when calculating the sales price due to the fact that there's zero coupon. So we have a fairly straightforward type of calculation where if we knew the effective yield to maturity, we would simply be present valuing the $1,000 back 10 years at whatever that rate would be. So therefore, if we're missing the yield to maturity, and that's what we're trying to find, one way to do that would be we could use either the future value calculation or the present value calculation and plug in our unknowns and then solve for the unknown. We'll also take a look at it in a few other different methods here. But for example, if you consider the future value calculation, we could say, well, I know what the future value is. It's going to be 1,000 at the end equals, and then the 550 is going to be the present value. That's where it stands at this time because that's the price, times 1 plus R. R is going to be the yield to maturity that we don't know, caret or to the power of 10. And then we can, of course, solve for R being the unknown. We could do that algebraically. I won't go through the algebra here, but that's one way you can set it up. Again, note how much easier it is to do given the fact that it's a zero coupon bond, because if it were a normal bond that also had interest payments involved with it, then we have to take into consideration two kind of present value components, and that makes it a lot more complicated to kind of back into the yield to maturity. You can do the same thing with the present value type of calculation. So if you have the present value, you're searching for the unknown, which would be R. So the present value would be present value equals the 550 equals the future value, which is going to be the 1,000, times 1 over 1 plus R, the unknown, what you would solve for, to the number of periods, which would be N. Another way you could think about this is if you had Excel and you were trying to work into this, you could use a goal-seek type of function, or you could use basically a rate function to do it. The goal-seek might be an easier way to think about it because you might have more practice with basically a future value or present value type of calculation. So in other words, if you had Excel, you could pick a number here for goal-seek. We might just pick a number like 10% and know that we're going to change that to what it will actually be, which in this case is going to be the 6.16, the answer, using the function of the goal seek. And then we can use our function down here which is not an algebraic equation, but you can kind of treat it that way given the fact that you have goal seek by solving for the unknown through kind of brute force, trial and error, but letting the computer do that. So in other words, we have the future value of the rate. The rate is the unknown. This is the one that we can choose this cell up here, just pick a random rate, 10% for example, and then expect to change that to get to the end result that we need it to be. And then we have the number of periods, that would be 10 on the number of periods, and then comma, comma, because it's not an annuity but present value of, future value of 1. And then the present value then would be that 550. And that would then give us a result that we know should be 1,000. That will give us the result that should be 1,000. If it's not 1,000, and it wouldn't be if we used 10% as our starting point, then we can ask Excel, we can say, would you please change this percent to what it needs to be in order for the end result to be the 1,000. And that way it allows us to use this function in an algebraic way in that if we have one unknown, even if it's not the end result of the function, we can basically kind of back into it or solve for that unknown, not by reworking the function, but rather by using the goal seek, so Excel can just basically use trial and error to force out the answer. So that's one way you could do it, or you could say, hey, why don't I just use the rate function? So let's see if there's a rate function that we could then use to calculate this. So then you can calculate it with the rate function, and it would look something like this, equals the rate, and then you have the number of periods. The number of periods would be 10 on the number of periods, comma, and then payment. We don't have a payment because it's not an annuity, so comma, comma, and then we've got the present value. The present value is the price, the 550, and then comma, the future value. And notice the future value has to be negative here to make this work. Future value is going to be the 1,000. You got the 1,000, and then comma and 0, I think, means that it's going to be calculated at the end of the period. And usually if you're in Excel, it'll give you kind of two options. Do you want to calculate it at the beginning or assume payments happen at the beginning or end? I believe that's what that will be, and we're going to say 0 here for that, and that'll give us, once again, the 6.16. Even after you've gotten the answer 6.16 with the rate function, I would still double check it with a future value calculation. So once I had the rate, I would still either do this calculation or double check it with the present value calculation. Just that makes me feel more comfortable. The rate function doesn't make me feel completely comfortable. It seems like a floating rate that I'd rather verify by checking it again. Now you can also think about this from the standpoint of the present value. So you might be looking, well, why don't I look at it? This is just how you might view it. And if you work with other people, they might do it some way different. And the better you kind of understand the relationship between present value and future value and how you can look at these problems different ways, the better you'll understand it. The better, the more flexible you'll be able to be, and the more easily you'll be able to work with other people. So you can also do it with the present value function. So we could say, okay, the present value, if I plug this into the formula, the present value would be the 550 equals the future value of 1,000 times 1 over 1 plus r, that would be the unknown, to the power of n, which would be 10. And then you can solve for the unknown. If you did that with our goal seek type of format, you could use this same kind of algebraic idea with the Excel function and then use goal seek to back in. So in other words, once again, we might use the 10% as our test point, our starting point for the percent, plug in the present value formula, which would be the rate. The rate would be the unknown, which we would give the 10% so that we could have a starting point, comma, number of periods. Number of periods would be 10. And then we have comma, comma, because it's not an annuity, but present value of 1. Future value would then be the 1,000. We know that the end result needs to be the 550, this 550. If we got to some answer other than 550, which we would if we just picked 10%, for example, then we can ask Excel, would you change this percent until we get to the end result that we need it to be? We know it should be 550. Goal seek is the function you can use to do that. And again, that allows us to do kind of an algebraic type thing, solve for that one unknown, but instead of algebraically reworking the equation, using a function and then basically backing into the unknown, in this case the rate, by using goal seek to just trial and error and force until it gets to the correct answer. You could also use the rate function here. So if you did the rate function and got the answer to 6.16, you can replug that in to the future value calculation to double check it. The end result should be 1,000. Or you can replug that in to the present value calculation. The end result should be the 550. So if you plug it in the future value calculation, end result should be the end point, the maturity point. And if you plug it into the present value, the end result should be the starting point, which would be the sales price.